In this lecture, we're going to talk about electrolysis, which will let us talk about the stoichiometry of oxidation-reduction reactions. Let's consider, right, an electrochemical cell, right? We've got zinc metal and zinc ions in solution, iron metal, iron ions in solution, and we've got it set up so that the left side is the anode. This is where oxidation is occurring. The right side is the cathode. That's where reduction is occurring. Right? So electrons are flowing through the system this way. So as electrons are pulled out of the zinc, then zinc is being converted into zinc ions. Right? So that electrode is losing zinc. And at the same time, as extra electrons build up in the iron ions are picking up those electrons and depositing as iron metal. So that iron electrode is gaining mass as it gains iron. And so there is a conversion, and we need to be able to account for that. Okay, so before we had a voltmeter in our line. What if we change that to an ammeter? That is something that measures the current, right? And so current is measured in amperes or amps, right? And 1 ampere is equal to a current of 1 coulomb of charge passing that point per second. So it's coulombs per second, okay? And so now, if we know how much current has flowed, we can figure out what the change in mass would be. So here's our cathode reaction, right? Iron ions being reduced to iron metal. So let's consider that a current of 5 amperes flows for 8 minutes, right? How much would the mass of the iron electrode increase? Right? That is a reasonable question. Okay? So, how do we work that out? Well, we've got 8 minutes, but our definition of amps includes per second, right? So let's convert our 8 minutes times 60 seconds per minute. That will give us how many seconds our current flowed. And our amperes, what we call it amps, that's really coulombs of charge per second. So that will tell us how many coulombs of charge flowed, right? But we know that Faraday's constant, 1 mole of electrons, is 96,485 coulombs, right? There's our Faraday's constant, right? 1 mole, reducing 1 mole of iron takes 3 moles of electrons. And iron has a mass of 55.845 grams per mole. If we work that out, that should tell us how much mass that iron electrode will gain. And when I do the math, I get 0.463 grams, right? So our electrode would have gained a little less than half a gram, okay? So there is a stoichiometry. It goes back to where we were at the beginning of the class, right? It's about relating these definitions to come to a new answer related to all the other things. Okay? Okay, I hope you've paused and looked at this to see if you can solve it yourself before I do it. But if we take our 0.75 grams of zinc lost, right, the difference between this, and that was lost in 15 minutes, right? And we know that 1 minute is 60 seconds. That gets us seconds in the denominator. You know that 1 mole of zinc is 65.41 grams of zinc, right? That's zinc's molar mass. We know that it takes 2 moles of electrons are lost every time we oxidize 1 mole of zinc. Right, make that 1 mole of zinc. And we know that there are 96,485 coulombs of charge in 1 mole of electrons. Right? And if we go through and look at that, right, it is just like our other unit conversion problems, right? Grams of zinc, that's 1. Minutes, that's 1. Moles of zinc, moles of electrons, We are going to get an answer then in coulombs per second. And when we do the math, we get about 2.4585, which would probably be rounded to 2 significant figures here. So that would be about 2.5 amps. Okay, so this is just a couple of ways of putting together these conversions related to electrolysis, right? So you need to work on some of these problems because these, go back to some of our principles of unit conversion, right, to solve problems.